Alright everybody, welcome back to another video. In this lesson, we're going to be just polishing the game as much as possible before we get into deployment, which will be in the next part. So basically we just want to spend a few moments just touching things here and there and making the game really shine, so that when we deploy, people will be amazed by how good it is and they'll want to play the game for as long as possible. So if you want to follow along at home, you can come to tbat.me/projects, click on the Godot Golang course, and just scroll down to lesson 11. And if you want to download the source code for the end of lesson 10, you can just do that here with a link to the official GitHub release for episode 10. So this lesson is going to be structured in a way that you can follow each individual part, which won't rely on each other. So if you want to pick and choose whichever ones are important to you, you can just do that and you won't have any trouble following along. Otherwise, if you just want to follow along and polish up each part that I'm doing, just stick around and watch the video in order. With that said, let's go ahead and get started. First of all though, I'm going to quickly fix a bug that I introduced in episode 8. It's to do with consuming other players. So there's currently a server validation check for whether or not a player that's consuming another actor is actually big enough to do so. And on the client side, we're checking if the mass is greater than 150% the mass of the one who is going to be consumed. But on the server side, we are checking if the radius is big enough. So what we need to do is make that consistent, because otherwise the client is always saying, hey, I've eaten this player because my radius is big enough. But then the server is like, nah, your mass isn't big enough. And those two things aren't going to be the same. So we just need to come into the in-game state. We'll find our handle player consumed method. And just here we have a check to see if the player's radius is smaller than the player's. We just need to change this to mass. So I'm going to steal this variable here called other mass, and I'm going to move it above this check. And I'm also going to record our mass. So now instead of g.playerRadius, I'm going to use our mass. And instead of other.radius, I'll use other mass. And I'll just fix some of the wording here. And this is the correct validation check now. Also, we just want to probably move this check to the beginning of this method, just because this is a pretty simple check. It makes no sense to be checking if the player is close enough before we check if the radius is big enough, just because this is a simpler calculation than this. So I'm actually just going to move this, and I'll just move it up here to be the first check. Well, I guess I'll move it to be the second check, because here we're actually grabbing the other player, so we don't know what other is until we've defined this line. Alright, so that should be all good now. So next we're going to tackle the issue of currently players can close the game window to disconnect, and that will boot them off the server, so the server will stop processing their requests. But from the perspective of other players, it looks like they are still in the game. So if I disconnect the window as John, you can see Tristan thinks that John is still in the game, although his floating lifeless body is sailing into one direction. So what we want to do instead is create a new packet called a disconnect packet, and then we will broadcast that packet every time it's received on the server, or anytime someone closes their game window. So that means that Godot can listen to a disconnect packet and then remove that actor from the game. So I'll come into our packets.proto, create a new disconnect packet, and we'll give it a string of reason, because this will integrate nicely with our WebSocket client's close method, which also takes a reason. It's also nice to just log something to the game if we do want to include some more information. So imagine maybe the player was disconnected because they got kicked out of the room, or something like that. We could actually encapsulate that information in this reason payload and then print that out to the screen. So I will create a new utility helper function just to create a new disconnect packet, and I'll give it a reason argument. So first things first, we can listen to the event that the client has closed their game window. So in clients/websockets.go, we do have this close method. And what we can do at the very beginning of this method is just broadcast a new disconnect packet. So because we are broadcasting this message, it means we need to check for this message in the in-game state. So we can come to our handle message method and add a new case. And what do we want to do when we receive a disconnect message? Well, it depends if it came from our client or not. So if it did come directly from our client, it means that we are going to need to disconnect ourselves, and then we will broadcast that packet to everyone else. So we'll do the broadcast first, and then we will set our state to back to the connected state. So this will mean that we're ready to receive login and registration packets again. And on the Godot side of things, we will return to the login screen. And we will just return here so that anything after this line will be in the event that another player sent us this disconnect message. And if that's the case, we can forward this directly to our client so the client can handle this event. All right, so let me rerun the server and we will do some work on the client. So I'm going to open my ingame.gd script and I'll add a new case to my on WebSocket packet receive function. So if packet.has disconnect, handle disconnect message. So what do we want to do on the client side when we receive a disconnect? Well, we can look them up and see if it came from a player that's currently in the game. So if the sender ID is in our players dictionary, then we can grab that actor and we'll grab the reason as well from the disconnect message. And then we can log some info that just says player disconnected because reason. And then we can simply remove actor or remove player, I think is what I've called it. I might actually rename this to remove actor. It's just a little bit, I like to say player to represent the player that we control. And I like to say actor for like a networked player, although I'm not the most consistent with this. So if it were up to me, I would actually rename this dictionary as well, but I think we're using this in too many places now. So you're welcome to refactor if it bothers you though. But we're going to remove actor and we'll pass in the actor. I'll just fix this up so it should say actor.actorName. And this is all we need to do. So if I rerun the game, we should see that our new disconnect packet is being broadcasted and handled correctly on the client side. All right, so if I log out as Tristan, we should see him disappear on John's screen, and we should see a message gets logged that says Tristan disconnected. Okay, I do not see, he did not disappear and he did not get disconnected. So let's see. Oh, I see, I've made a huge mistake. So when we check the handle disconnect message in the in-game state on the server, I said that we were going to check if this came from our ID, but then I typed not equals. So it needs to be sender ID equals our ID. So that was a huge blunder. Apologize. If you just fix that up and rerun the game, it should be working. So let me try to log out as Tristan, and from John's perspective, he should disappear. Yeah, you can see he disappeared and it says Tristan disconnected because read pump closed. So maybe not the most helpful error message, but if you want to finesse that, then you're free to go ahead and do so in this WebSocket client close method. So we should probably go ahead and add a button for players to log out so they don't have to physically close the game window every time they want to leave. So if we open up our ingame.tscn scene in the 2D view, we can see that indeed the scene's looking a little bit sad. There's a few things that we can fix up at the same time that we add this button. So underneath my UI node, I'm going to add a margin container, a new margin container. I'm going to drag it up the top and nest everything inside the margin container, because then what I can do is set the theme overrides on the margin container, and I can set margin left, top, right, and bottom to say 20 pixels each. And I just need to make sure my margin container is using the full rect anchor preset. And I think that looks a lot better. So now things aren't touching the edge of the screen. I'm also going to put the line edit inside a hbox container because I want to put two buttons on either side of it. So I just need to make the line edit expand horizontally. And then I'm going to add a button on top, and I'll call this the logout button. And I'll make one as well, another button on the other side called send button. And I'll just set the text on these, so the send button will say send, and obviously the logout button will say logout. So this layout's looking a bit better. We just need to fix our code. Scroll to the top where we have our references to all of our nodes, and I added a margin container after the UI node, so I'm going to type margin container, and we added a hbox container before the line edit. Hbox container. So I'll just rerun the game to make sure I haven't broken anything. And that looks good to me. So our buttons don't do anything yet because we need to hook them up. So let me drag in references to the two buttons. And then we will connect them up in the ready function. And now we just need to define two new functions, on logout button pressed and on send button pressed. So for the on logout button pressed, all we're going to do is craft a disconnect message, send it off to the server, and then set the game state back to the connected state. We'll set the reason to just logged out, or I think they logged out. Just it'll make more proper grammatical sense in the way that we're printing it. And we will send that off, and then we'll say game manager dot set state, game manager dot state dot connected. All right, now when we press the send button, we're simply going to call the online edit text submitted, and we'll just give it a new text of whatever's currently in the line edit node. So this is really just a wrapper for this function. All right, so let's see if our new logout button works and if the send button works. All right, let me see if I can locate, get the other players all the way over there. All right, so I'll test the send button. Seems to work just fine. And now I will log out as John using the logout button, and it also logs just fine. So that's the disconnect feature, all done. And we've also improved the UI in the process. So now that our in-game scene is looking pretty good, we should probably revisit the connected scene, because this one still looks like garbage. So I'm going to give it some of the same treatment that I gave the in-game scene. I'm going to add a margin container just under the UI node, and then I'm going to put everything inside the margin container. And I'll set the margin container's anchor preset to full rect and set the theme overrides. So for the constants, I'm going to go with 50 pixels. I think that a bit more padding will look nice. And I'm also just going to center these buttons here. So I'll select my hbox container, and I'll just do shrink center as the horizontal alignment. We can also add a title. So to the top of the VBox container, I'm going to add a rich text label. I'll select fit content, and then I can just type the name of my game. So my game is going to be called Radius Rumble. And the really cool thing is if we select BB code enabled, we can use BB code to style our title. So this is a really simple, very simple way to do some pretty cool styles. So I guess first of all, I will center the text. So I can type center tag and then close center tag. That will make it nice and centered. I can also increase the font size. So I'll come to theme overrides, font sizes, and I'll do the bold font size because then I'll make it bold. So I'll make bold font size, say 48 pixels. And then if I add a B tag, that will make it bold and increase the font. So to fit with the theme of my game, I'm going to make it appear like it's rumbling. So I can use the shake tag. So that looks pretty cool. And just because it's cool, I'll just go ahead and use the rainbow tag as well. So that looks pretty cool. So I think I'll go ahead and use that. If you're interested in what else is available, there's a pretty cool section in the Godot documentation about the rich text label and about BB code. So this shows all of the tags that are available. As you can see, there's quite a lot of them, so definitely encourage you to experiment. So I think it's time we change this gray background image to something that looks a little bit nicer. So I'm actually going to create a new Sprite 2D node. This will be separate from the UI canvas layer. This will just be under the root node. And I'm going to find my floor.svg resource and just drag it into this texture slot. I'll set the region enabled, and the width and height of the region I'm going to look up in my project settings. So if I go project settings, come down to display window, my viewport width and viewport height is 1152 and 648. So that's what I'm going to use for the width and height of my region. And I'm just going to want to enable texture repeating. So I'll come to texture repeat enabled, and I'll also just set the offset centered. I'll untick this just so it starts at the top left corner. So that's already looking a lot better, but I think we could make it look a lot cooler if we added a cool shader effect. So I like to use this website, godotshaders.com. This website has lots of cool free shaders that you can use in your game. And the one that I'm looking for is called Sign Morphing. And that's this one here. So if you click on the shader you want to use, scroll down and you'll see the shader code. So I'm going to copy that code. And then with my Sprite 2D node still selected, I'll come down to Material, and I'll click on this drop down list where it says empty and create a new shader material. And then I'll just click on the shader material item. Under shader, I'll click the drop down and click new shader. And I'm going to save this shader under my resources folder, and I'll just call it background effect.gshader. So I can create that. And if I click on my background effect.gshader here, it will open up the shader editor at the bottom of the screen, where I can just replace this default code with the code that I copied from godotshaders.com. And you can see now that my shader is active. So that looks pretty cool. So I'll just make sure I didn't break anything. And it looks like I did forget to update my code. So all I did was add a margin container. So I just type margin container after the UI node. So if I try that again, wait, I need to do it here as well. And everything on this page appears to be working again. And that leaves us with the high scores board, which still looks pretty sad. So let's go and fix that. I'll just give it the same treatment that I did for the login screen. So I can actually copy my Sprite 2D, and maybe I'll just call this background. So I can copy this, and then I can open up my browsing high scores scene, and I can just paste that there. So now now the browsing high scores scene has the same background. And I think this scene already looks a bit better, so I might just leave it as it is. But if you want to spruce it up, you can feel free to do that. So it'd be really cool if players could choose their color when they register, so that not everyone looks the same. So having a separate registration screen would make a bit more sense, because currently there's not enough space to have like a color picker. And also, most websites will have a confirm password field, so that if someone made a typo while they were filling out their password, it's unlikely that they're going to make the same typo twice. So the confirm password field will help avoid that. So because of this, we're just going to make a completely separate register form. And we can also separate our login form. And on this connected scene, we can decide which form we want to display based on what the user is doing. Oh, and I suppose real quick, before we get into that, let me just add some placeholder text to these fields. So I'll select the field, and then under placeholder text, I'll type username and password. And one more important thing I forgot is the password should have a secret enabled. So if you select the line edit, come under secret and choose secret on, this will make it so that whatever you type in here will appear just as blocks. And if you're on mobile, you'll want to set the virtual keyboard type to password, and that will just prevent auto suggest from exposing what the user is typing. So when you're typing on your phone and little suggestion keywords appear on top, if you select password for the virtual keyboard type, that won't be the case. Okay, so let's create some new classes. These will be our login form and registration form. So we'll come under classes, create a new folder, login form, and I'll make another folder called register form. So let's do the login form first because we can just pretty much copy and paste everything. So I'll create a new scene called login form. And we'll make it inherit from VBox container. Just because that's this node here that we're going to copy and paste. All right, so let me switch to my connected scene again. And I'm going to select all of this under the VBox container, choose copy, come back to the login form scene and just paste. And I'll make the login form anchor preset full rect. So this will take up as much space as we give it. And let's remove the register button. And I'll also just get rid of the rich text label title. And I'll get rid of the log as well. I didn't need to copy those. We're just after the username, password, login button, and hiscores button. So I'll save all of that. And then back to the connected scene. I'm just going to get rid of the username, password, and hbox container. And I'm going to click and drag my new login form in between the title and the log. And let me just rename this to title, just to make it clear, but it doesn't matter. So now we have our login screen back. So let me go ahead and attach a new script to our login scene. This is our login form.gd script. So what we want to do is emit a signal every time a user submits this form, and then we can listen for that signal inside our connected.gd script. And we're going to fix all of this up after we define the signals in the login form. So I'll give this a class name of login form, and then I'll just drag in references to everything that we're going to need. I'll add my underscore, and I'm going to call this username and password field. And then I'll define a new signal called form submitted, and it's going to take a username and a password. So we can emit this signal when we click the login button. So let's set up our ready function so we can connect the signals. So login button dot pressed dot connect on login button pressed, and let's also connect the signal to the hiscores button. So we can actually copy the on hiscores button pressed function from the connected scene. So I'm just going to copy this. I'm actually just going to cut it because we won't need it from the connected scene anymore. And I'll define our new login button pressed handler as well. So this is just going to be form submitted dot emit, and we'll use the username field's text as the username and the password field's text as the password. So this is a pretty simple script. It's really just a giant wrapper for this form submitted signal, which we're going to listen to in the connected.gd script. So let's come back to connected.gd, and we're going to get rid of the references to the hiscores button, register button, login button, and the username and password fields. Instead, we will drag a reference to our login form, and we're just going to connect our login form's form submitted signal to our on login form submitted handler. And this form submitted handler is just going to be a replacement for our previous login button pressed handler. So I'm going to rename on login button pressed to on login form submitted. And this is actually going to accept a username string and a password string, which we can use in place of the old username field's text and password field's text. And for now, I'm just going to comment out the on register button pressed. So that should be all good to go. Let's test it out and see if we can still log into an existing account. So we'll have lost the ability to register, but if we had an account already registered, we should be able to log into it. Cool, so that's working as expected. And we can still go to the hiscores board as well. So let's get our registration form set up. So I think I'm just going to copy the login form.tscn or duplicate it, and I'll call this register form. And I'm just going to drag it into the register form folder. So now if I open it up, it should look the same as our login form. And it also still has the script attached. So I'll just need to make sure I detach that login form.gd script and rename all of this stuff to register. I'll remove the hiscores button, or I guess I'll rename it to cancel button. So this will be a way to get back to the login screen. We can click the cancel button, and I'll rename this button to a register or a confirm button, and I'll set the text to confirm. I'll duplicate the password field and I'll call it confirm password. Set the placeholder text appropriately. And then I will attach a new script, registerform.gd, and I'll drag in references to all of the stuff that we need. Give it a class name, register form, and I'll add all of my underscores, and I'll call these fields. And I missed out my username field. All right. So let's define our signal form submitted. It's going to take a username and a password, same as the login form submitted signal, but it's also going to take a confirm password. Let's also make a signal for the form cancelled. So basically this will get emitted when we click the cancel button and we want to go back to the login screen. Let's hook up our buttons. So the confirm button pressed handler is simply going to emit the form submitted signal using the username fields text, the password fields text as well, and the confirm password text. So we're not going to be doing any validation logic to make sure that this matches this. We won't be doing that in this script. We will be doing that when we listen to this signal in the connected script. So this is really just going to be emitting what the user types in, like for like, and we'll worry about validation in the connected state. So let's also get our cancel button handler. And in this case, we're simply going to emit the form cancelled signal. All right, so that's looking pretty good. Let's come back to our connected scene. And we'll click and drag our new register form in here as well, just next to the login form. And you'll see that they are appearing stacked on top of each other. But what we can do in the code is we can dynamically toggle the visibility of one or the other, depending on which one we want to do. So by default, we're just going to hide the registration form, and we can show that once we click a register button. And we'll be adding a register button in a minute. But for now, let's go ahead and connect these signals to our connected script. So we'll add a reference to our register form, and we can connect the two signals. And let's define the handlers. So the form submitted handler is basically going to be the new version of this old register button handler. So I'll just rename this on register button pressed to on register form submitted. And it's going to take a username, password, and confirm password. And we can use that instead of the old username fields text and password fields text. And we'll only do this if the two password fields match. So we'll say if if password fields or if password does not equal to confirm password, we can log an error, passwords do not match, and then we'll just return. And if the password fields do match, then we're going to send a new register request message to the server, same as what we were doing before. And let's also connect the form cancelled signal to a handler. And what we want to do in this case is we will hide the registration form. So register form.hide and login form.show. So actually, if we start with the register form visible, we can test this. So we'll start with register form visible and the login form hidden. So this is sort of simulating the scenario where we are registering, even though we don't have a button to do that yet. So let me try to register a new player here. And it says registration successful. So this is working as intended. And if I click the cancel button, it should hide the register form and show the login form, which it appears to be doing. We just need to show the login form by default, and then we need a button that will bring us to the register form. So let's do that. So instead of a button per se, we're going to add a piece of text that will appear below this login form or above the log. So I'm going to add a rich text label and I'll drag it above the log and I'll just set it to say fit content on, and I'll turn BB code on as well. And I'll just make it say don't have an account, create one here. So this create one here text is going to be a link that the user can click and it will take them to the register form. So let me just make this look a little bit better. Well, first I'll make this a link. So you can use the URL BB code tag. And if you type equals, and then you can type a word here, and this word will be a special keyword. So I'm going to type register, and then we'll close off the URL tag. That will make register a special keyword that we can listen for in the script when this link is clicked, and it will do a certain thing. So let me just center this and make it italic. And I'll also make this URL bold, just to make it more clear that you can click on it. Because there is a faint underline, but it's pretty faint. And I can even set the color to something a little bit more aesthetic for the link. So I can type color equals and then a hex code for a color that I like. And I'll close off that color tag. So that's looking pretty good. So let's connect up that URL signal in code. So we'll need a reference to the rich text label, which I'm going to call register prompt. And I'll drag this here. And then we can say register prompt dot meta clicked dot connect on register prompt meta clicked. So let's define this handler down here. And if we look at the meta clicked signal, this is a bit of a strange one because the argument is a variant. So we don't know the type. It can be dynamic. So we need to check that this meta is going to be a string called register. So basically whatever we typed in here in the URL tag is what we're going to need to check to make sure that the meta is equal to as a string. So I'll pass in a meta argument, and then we can do if meta is string and meta equals register, then we will go ahead and hide the login form, hide the register prompt, and show the register form. And because we've got this register prompt, we need to make sure that we show this when we go back from the registration form to the login form. So as well as showing the login form here, we're going to show the register prompt on the register form cancelled callback. So basically this is the inverse of this. So let's see if that works. So don't have an account, create one here. If we click on it, it will bring us to the registration form. And then if we click cancel, for some reason it duplicates everything. So let's see what's going on there. Oh, I typed register form twice. I should have said register prompt dot show. So let's just quickly make sure that works. Yep. All right. So that looks to be working. So that's our registration form revamped. And now our login scene has the potential to show dynamic content, which is going to be really useful for us because we can modify our register form to include a color picker, and we can let users choose their color when they register. So let's allow the server to accept custom players from the register request packet and store them in the database. So we'll come back to our server code, and there's many different ways that we can think about storing colors. One way is to store each of the RG and B parameters as their own separate integers. So we could have an R value between 0 and 255, and we could have that as RG and B. We could do that. We could also store colors as a hex code like that. And that's another valid way of storing a color on a database and also transmitting a color across the network. But the way that's going to be most convenient for us is sort of more similar to RG and B, but instead of sending them separately, we can take each one of them, which is a value between 0 and 255, and we can basically just smash them together to form. So these are 8-bit numbers from 0 to 255. That's what you can represent with 8 bits. And if you add all of these bits up together, we can get 24 bits. So we can represent a color with a 24-bit integer. But if we throw an alpha into the mix as well, so the alpha is also going to be an 8-bit number, we can get a 32-bit number from these payloads. So that's how we're going to be storing the colors in the database and also sending them across the network. And Godot has a really nice function that will allow us to convert a color to a 32-bit integer in that way. And also there's an inverse function that takes a 32-bit integer and can convert it into a color. So this is going to be the most convenient method for us. And it is also the most space efficient way as well. So let's create a new packet. Well, actually, let's modify our existing packets. So we're going to modify the register request message to accept a color, which is going to be a 32-bit integer. And the same thing for the player message. Its final parameter is going to be a 32-bit int color. So I'll recompile my protocol buffers. All right. And let's add a color field to our player game object. So we'll come into internal server objects gameobjects.go, and we'll add color, which will be an int32. We're also going to need to update our helper function for creating a new player. For creating a new player message, and we'll just add color is going to be player.color. Let's also update our database schema to include a color column in the player table. So let's come to internal server db config schema.sql, and under the players table we're going to add a new column called color. This will be an integer, and we'll say not null. This means we're going to have to update our create player query. So we'll come to config/queries.sql. We'll find the create player function, and we're also going to be inserting a color. So let's recompile our SQL using sqlc. Now we can come back to the connected state. So states connected.go. We'll find where we're handling the registration requests. And let's find where we're creating a new player in the database. So we're adding a new user here, and here's where we are adding a new player. I'll just add a comment there to make it easier to find in the future. And we're going to pass in our new color parameter. And we're going to use the message.registerRequest.color. And this needs to be cast as a int64 because that's what our create player params is going to expect, annoyingly. But when we cast up like this, it's not going to affect the RGB values in any way. So now let's just update the login request handler. And when we set the new state to the in-game state and we supply the new player object, we'll just supply the color to be a player.color. And we'll just need to cast this to an int32. So we cast this back down. So that's the server all set up to handle and store colors. So I'll go ahead and rerun the server. And if I register with a new player now, we get an error. Oh yeah, so I forgot to, I just need to delete my old database. So I'll come and delete the server/cmd/db.sqlite file. And I'll just rerun. So basically the old data was not compatible with the new schema, which is something that you would ordinarily fix in production with a migration. But since we're still in development stage, we can just afford to delete our database every time we need to change the schema. So let's create a new user. And they should have a color column now. So let me select star from players. And we can see my test player now has a color of 0. So this is just the default value, which should be, I believe this should correspond to black. Okay, so now let's let players choose their color when they register. So we're going to add a color wheel to our register form. So just after the confirm password field, I'll add a color picker. And there's a lot of stuff here, but basically we're just going to get rid of all of it. So come undo customization and we'll just uncheck all of this. So we just have the color itself, and you can choose the picker shape. So there's a few ones to choose from. I'll be going with the rectangle wheel. And now we just need to hook this up to our script. So we'll come to register form.gd, drag in the color picker, and then we're just going to modify our form submitted signal to accept a color. So this will still just be a color at this stage, and we'll convert it to a 32-bit integer before we send it in the connected script. So when we emit our form submitted signal, we will just supply the color picker dot color. So now in the connected script, when we receive the register form submitted, we need to accept a color, and then we can include that in our register request message. So register request message dot set color, and then this is where we need to supply an integer. So we can type color dot to RGBA32. So this is a function that turns it into the 32-bit integer representation. So we'll do that before we send the packet. So now if I register, and if I actually choose a color, I'll just choose a red color and confirm. If I check the database again, my new user now has a different color. So we can see that this is indeed being received on the server and being stored in the database. All we need to do now is we need to display it to the player when they log in, because currently we're still using this default purple color. All we need to do is come into our actor.gd script, and we will allow the actor to store a color. So this will still be a color, and we'll convert it to a color as we receive it. So we'll modify the instantiate. Wait, this has been called instatiate the whole time. Oh, that's crazy. It should be instantiate. Huh, well, I guess it didn't matter. Yeah, there was a typo the whole time. Oh well. Let's come to our actor, and we will set the color. So we need to accept a color argument just before the isPlayer argument. So this will be a color. And I know this argument list is getting quite long, so it would be probably better to make this like a struct or something, but for now this is going to be fine. And we can just set the actor.color equal to the color argument. So now we need to come to our ingame.gd, and where we are instantiating a new actor, we need to be able to pass in a color payload. So I'm going to put the word color here between speed and isPlayer, which means we're also going to need a color argument here between speed and isPlayer in the add actor method. And then here, where we're calling the add actor method, we need to supply a color. So I'll just type the word color there, which means we're going to need to define a color variable. This is going to be equal to the player message.get color. But remember that this is a integer and we are expecting a color. So we need to convert this using the color.hex, and then we can use the get color to get our integer. So this is called hex, but it says it's the inverse of 2RGBA32. So this is what we want to use. So we should be able to log in now. And if I log in as my test3 account, we should expect to be a bright red color, but we're not, because we need to remember to draw the color when we draw the circle. So instead of using this hard-coded color, we'll type in our color parameter. So now when I log in, you can see I'm the same bright red color that I selected when I registered for this account. And let's just, for good measure, we'll register another account and we'll make it like a nice green color. And we'll log in, and you can see that we're this same green color. And if I logged in as my other user, and if I tried to locate the other player, it's hard to see, but you can see that maybe it'll be easier. Yeah, you can see there's that bright red player over here, and then that green color is over here. So other players can see the colors that their friends have selected. So that's working as expected. So this next one is going to be a little bit difficult to notice, if you've been playing just locally this whole time. But basically, small imperfections in the synchronization on the server can cause a little bit of jittering. So you might notice the player sort of jumps around a little bit every time it syncs, because we have this in-game logic to update the player. So in the update actor method, we just check to see if the actor's position is a certain distance away from the server's last known position. Then we simply set the actor's position equal to the server's position. So this is what causes a bit of that janky sort of movement. And I think I can demonstrate this a little bit better if I simply set the actor's speed equal to 10% more than the speed it should be. So this is going to cause that synchronization to kick in more often, and that snapping back should be a bit more apparent. So I can just demonstrate this. So yeah, now it's pretty obvious that we're getting sort of snapped back every second or so from the server. So this is what we want to make look a little bit smoother. So let's try to do that. So our approach is basically our actor is going to keep track of the server's position. And this is just going to be where the server thinks the actor should be. So every time the server sends an update in the in-game script, instead of setting the actor position directly like this, we're actually going to set the server position. So actor.server position is going to be updated instead. And then what we can do is, because we're going to have an accurate server position, and then we're going to have our maybe inaccurate real position, we can just constantly make small micro adjustments throughout the game to always tend towards nudging the player towards the server position, just in a more gentle way. So in the physics process, as well as updating our position as we normally do, we're also going to update a server position, and this will just keep the server position roughly accurate to where we're moving as well. And then we can tend the actual position towards the server position. So this will just be an interpolation strategy. So we can use server position minus position. This will get the difference in positions that we need to tend towards. And then we can just soften the blow by multiplying this by 5%, just to make it a little bit more gentle. So we're always going to be moving 5% closer to the server position with this line of code. So let's go ahead and see if this looks any better compared to what we had before. So you can see now there's no more of that jerky movement, and everything looks really nice and smooth. So you can barely even tell that we've set it to 1.1 times faster than it should be, and we're actually getting snapped back every 1 second or so, but you can barely tell. So maybe if I make it a little bit more dramatic, you can sort of see what's going on. So instead of 10% faster, let's make this 50% faster. So this really shouldn't be happening in a real scenario, but this is just for demonstration purposes. And you can see here, it's still not really obvious, even though the game still feels quite responsive. So we're not really sacrificing any responsiveness or accuracy for this. So I'm just going to set this back to normal, and our game should feel nice and responsive. So just as a final demonstration, here's something I prepared earlier. So you can see here, this is what it looked like before. If we draw the server position as like a blue ghost, and then the real position, the in-game position, is going to be this solid red color. This is what it was happening before. Every time we got too out of sync, the server would send us a new position, and then we would immediately snap to it. But this is sort of what's happening now. So we're just making micro adjustments until we sort of close that gap, and we'll smoothly move into that server position. And the added benefit of doing it this way as well is when we consume another player, or if we get consumed, because the server gives us a new X and Y position, and we get instantly teleported to that position, it will sort of appear like we're being whizzed across the map because we're actually fastly interpolating to that new position. So if I eat Tristan here, it's going to look like he's getting sent across the map. So that's a much more dramatic animation, which makes it more apparent that you've been eaten. So I think this is an unintended side effect, but I think it's a very welcome one. All right, so we just have a couple more small things to adjust now. So the first thing that I want to change is currently when you drop spores, they appear on top of the player. And I want them to appear underneath the player. So I just sort of exaggerated things just for the sake of this demo. I increased the starting radius and the spores drop chance, but you can see what I mean here. So the spores are appearing on top, which doesn't look very good. So let's go ahead and make those appear on the bottom, which is going to be a very simple fix. Basically, in the in-game state, in the add actor method, after we add a player to the world, we're just going to set the actor's Z index equal to 1. So by default, the Z index is 0, but we're going to set it to equal to 1 so that it's drawn on top of everything. So if I run again now, we should see the spores are actually appearing below the player, and you can only see them after the player has moved out of the way. So I think this just looks a lot better. It's a small change, but it adds a lot to the feel of the game. So I'll just go ahead and undo the changes I made just for the sake of this demo, which, if you were interested, was I just changed this line of code here to 100 instead of 20. And I also updated the probability to always be half instead of scaling with the player's radius. So I'll just undo those now. Another thing is currently we allow the player to zoom out as far as they want, basically. And this lets them see the entire game world just by scrolling their mouse wheel. This isn't exactly the most fair, because any player who can zoom out the furthest and see the best will be able to win. So instead, what we want to do, and this will help improve the game feel as well, is zoom out automatically for you as you grow, and then optionally allow the player to zoom in if they want to get a better view of something, like take a screenshot or something like that. They can zoom in, but they can only zoom out past a certain value, dependent on how big they are. So to achieve that, we're going to be rewriting things a little bit. First, I'm going to define two new variables. One is just going to be called target zoom. And I'm going to initially set this as we're going to be 2 times zoomed in. So this is when the game starts, we'll be at a magnification of 2. And I'm also going to make one called furthest zoom allowed. And I'll set that equal to the target zoom initially. So our goal is to update this furthest zoom allowed every time we grow. And every frame, we're going to be setting the camera. We're going to be setting the camera zoom equal to this target zoom, which is going to be capped by the furthest zoom allowed, but it can be also controlled by using the mouse wheel. So we're going to put a call to a method in the radius setter, and we're just going to say this method is going to be called update zoom. So that will take the new radius and it will update the furthest zoom allowed variable. So let's come and define that function. So we'll just make sure that we are indeed the player. So if not is player return, because obviously we only want to be affecting the camera of the player object, not other actors. So now we're going to update the furthest zoom. So I'll say new furthest zoom allowed, and that's going to be 2 times the ratio between the starting radius and the current radius. So basically, this number will be smaller the bigger we get. So it'll be close to 0 as we get very large. But as we're starting out, this number will be close to 1, which means that overall, this whole thing is going to be close to 2, which is the starting magnification. And as we grow and grow and grow, it's going to tend towards 0. And if we set the target zoom to this thing, it's going to have the effect that the camera zooms out as we get bigger. So let's just only set the target zoom if we are currently all the way zoomed out, because if we're a little bit zoomed in and we're looking at something, we don't want to interrupt whatever the player is looking at by zooming them out automatically. We'll only do the automatic zoom if the player's already scrolled out the full distance. So we can check that by seeing if is equal approx target zoom furthest zoom allowed. And we just have to use this is equal prox method instead of checking equality directly because we're working with floating point numbers. Then we can update the target zoom. And we can also update the furthest zoom allowed. So then in our input function, instead of affecting the camera's zoom directly, we are going to be affecting the target zoom. So I'll replace camera.zoom.x with target zoom. And we don't need this camera zoom.y equals camera zoom.x anymore. Instead of capping the furthest zoom out to be 0.1, we're going to cap it as furthest zoom allowed. So that's our new input event. And currently we're setting target zoom, but we're not actually changing our camera according to it. So let's come to a new function. We'll call it, we're going to override the process function. And this function just gets called every frame, but it's separate from this physics process. So the physics process might get called more or less than the process function. The process function should be just for non-physics stuff, such as this. So we're just going to try to smoothly interpolate the camera zoom to the target zoom. So we can check if not is equal approx camera.zoom.x to the target zoom. Then we will update the camera zoom. So we will subtract a vector with 1 in each coordinate multiplied by the scalar camera.zoom.x minus target zoom. So this difference in zoom levels here is going to be what we can use to tend the camera zoom towards the target zoom. And this should be camera.zoom. And we can soften it up by multiplying it by 5%. So this will just affect how quickly the camera tries to meet the target zoom. So we can get some smooth camera movement this way. So we can save that and run our game. And we should be zoomed into 2 times when we start up, as you can see. And each time we eat, the camera will smoothly zoom out a little bit. And if I scroll out right now, so I'm scrolling down on my mouse, nothing's happening. But if I scroll in, I can smoothly zoom in like that. I can zoom out again further than I could before because I've grown a little bit, so my further zoom allowed has been updated. So the only thing left to do is we want to change the size of the text for the nameplate, because it gets a little bit hard to read as you grow bigger. So the nameplate should also scale with the player. So let's try to do that. What we can do is just come into our update zoom function. And at the beginning, so we want to do this for all actors, not just the player. So we'll do it before this early exit here. We will just check if the node is ready. And we just need to check the node is ready because we're going to be updating one of its properties, one of its child nodes. And that won't be possible unless the ready method has actually been called. So then we can just say nameplate.add theme font size override. And the property that we're overriding is font size. And the new value we're going to be setting it to will be whichever is bigger, either 16 or the half the radius. So we want 16 to be the minimum font size, and half the radius will be what the font size will be beyond that. So we should be able to see now the font size will look a lot more legible. So we're still at font size 16, but now you can see the font size is growing. And the last change that we're going to make before we get ready to deploy is we just need to make this look a little bit more accessible, or a lot more accessible. So currently in these parts that have white text on a blue background doesn't look very readable. So we're going to add a little bit of a shadow just to make the text stand out. And we're also going to increase the overall font size for all of the text in the game, just to make it more readable for users with like poor eyesight or mobile users. So the way we're going to do that is we're going to create a custom theme. So let's open up our resources folder, and we're going to right-click resources, create new resource, search for theme, and we're just going to call this game theme, gametheme.tres. So we can apply our theme to all of our scenes. So we'll come into our browsing high scores scene, and we're going to select the VBox container, and we'll choose theme, and we'll select quick load under theme and choose gametheme.tres. And let's also do the same for our connected scene. Choose the margin container. We're basically just trying to choose the node that's straight under the canvas layer. Choose theme, quick load, resources / game theme. And we'll also just do this on our in-game scene. So we'll choose the margin container as well and override the theme here. So now what we can do is we can open up our gametheme.tres resource, and this will open the theme editor down here, and we can start making changes. So these are all the different kinds of UI elements we can have in our game, and this is a preview of what it's going to look like. And over here we can select nodes that we want to override a property for. So for instance, if I want to make the button size bigger, I'll choose button, and then I can choose this font size tab, and I can click this little override item button, and I can change it from font size 16 to 24. And that will update the preview. And because we've already applied our theme to our scenes, it will also update in our scene viewer as well. So let's go ahead and do the same thing for labels. So we'll add a new override for a label, font size 24. And you can see that updates there as well. Let's also do rich text. We're going to override each and every one of these font size attributes, and we'll set them all to 24. If we look at our connected scene, we can see that the rich text is also a bit bigger. And just to make the title stand out more, I suppose I will go ahead and increase the title size as well, just since everything else is bigger. Let's come back to our theme editor, and I'm just noticing the line edits need to be bigger as well. So I will add line edit, font size will be 24. And let me just check to see if there's anything else we missed. This looks good, this looks good, and this looks good. So I think that's all we need to do in terms of the font size. So let's also make this text a bit more legible. So let's open up our game theme in the theme editor, and we'll come to label. And then under constants, we're going to set the shadow outline size to 7. And then under the colors tab, we'll set the font shadow color. I'm going to set a hex code for something that I found to be that works well with the colors in the background. So 30, 17, 08, and 72. I think that looks quite good. So I'm going to use that. And this is a lot more legible now. So if we switch back to the in-game scene, we can see that this has a nice shadow as well. And if we switch back to the connected scene, we can see that the rich text still needs to have a shadow as well. So let's come back to our editor and we'll select rich text label from this type dropdown. Set the constant for shadow outline size to be 7. And then we'll set the color for the shadow to be this color. Just so that it looks like that. So I think this is looking really nice. This looks a lot more accessible. There's obviously a couple more improvements we could make. Like we could make this yellow color a bit more themed. We could set it equal to this color here. And we could also make it so when we press enter in this line edit, it will search for us. But I'll leave that as an exercise to you guys. So I think we've polished this game up quite a lot and we can play it. I guess actually just before we go, the scroll bar here, we probably need to increase the size of our little widget in game for the scores. So let's just, last thing we do, let's select the high scores node here, and under layout, let's set the custom minimum size to be a bit bigger now. So maybe 400 by 200. All right, so now our game is looking really nice and we should be ready to take this to deployment. So if you've made it this far, give yourself a pat on the back. You should be proud of what you've achieved. We've got a fully working MMO game, which can be played in the browser with your friends, as long as we follow the next episode. Before I go, I'll just remind you one more time, not to be shy to join the Discord channel or leave a comment in the YouTube comments below if you had any questions. This Discord channel has 97 members, and these are all game developers who are following along with this course, and we're all welcome to discuss anything that we like about the course or just anything at all. So feel free to join the course or just leave a comment in the YouTube video and leave a like on the video if you liked this part. Until then, I'll see you in the next one, which is the final video.